All right, the last thing I'm going to talk about here is unit vector notation. So in math and in science and engineering, we're used to seeing the x-axis here, the y-axis here, and if we had a third direction, z, it would be coming out of the page at you. But sometimes it's not convenient to have the x and y's rotated like this. So sometimes you might see in a book that this is z, and this is x, and y is coming out to you. So as we get in more complicated situations and courses, not only are we in 3-space, but we're also in rotating axes around as we need to for the situation. So we had to have some way to standardize what direction always points in the x direction, what points in the y direction, what points in the z direction. So we came up with something called the unit vector. It's a vector that has the value of 1, and it points in a certain direction. So the first unit vector is I. It always points in the direction of x. And a unit vector has, instead of a half arrow on it, it has like a caret sign over it. And in the y direction, it has a value of 1, but it's called j. And in the x direction, the z direction, it's called k. So one way that we write vectors is to write them in something called unit vector notation. So let's say that you have the vector 10 newtons and 20 newtons. Remember, this is my x and my y. So if I wanted to write this vector, so let's just call this vector A, I could write it as 10 in the I direction plus 20 in the j direction, and there is no k direction for this. And I just put parentheses around it and put a newton there so I don't have to write newtons all the time. And all this is analogous to writing it as an xy coordinate, but you're putting your x coordinate plus the I and your y coordinate plus the j. And you're not really going to add these numbers, like physically add them, but you're going to add them tip to tail by drawing a right triangle if you wanted to find the resultant. So it's just a notation that we use. If we had the vector -2 meters, 0 meters, and 20 meters, so now we got x, y, and z, that vector would be -2i and no j, so I could just skip that one, plus 20k meters. If I just had a vector that was 100 newtons at 0 degrees, it's pointing in the east direction. So its x is 100 newtons. And so in unit vector notation, that would just be 100 I newtons. So if we're given the magnitude and the direction, we have to resolve it and find the x and y, and then we can write it in that notation. Here are a couple examples. Okay, so the first thing I'm going to do is I'm going to find the x for this. Well, it's 0 degrees, which means it's pointing in the east. So its x is 200 newtons, and its y is 0. So if I write that vector, and I'll just call it vector A, it would just be 200 I parentheses newtons. If I find the x component for the next one, which is 100 times the cosine of 210, I get negative 86.6. And I get a y which would be 100 times the sine of 210 of negative 50.0 newtons, that vector would be negative 86.6I plus negative 50.0 J newtons. And if I'm given the X and Y outright, I don't have to do any calculation because I already know what X is. X is 30 in the I direction and negative 60 in the J direction. And for vector D would be negative 100 in the I direction plus 50 in the J direction. You and I, in this class, will probably not have things in the third direction, the K direction. You'll probably either have them all in the X direction, all in the Y direction, or in the X and Y direction.